Let's take a limiting problem that has been asked by one of my students as doubt, and the question we can see is that if xn plus 1 is root over 1 plus xn by 2 and mod x naught is less than 1, n greater than equal to 0, then we need to find out limit n tends to infinity root over 1 minus x naught square divided by x1 x2 x3 continuous product up to xn plus 1. This is equal to which option? So to start with, we can use this relation that is given to us. So if you use this particular relation and if we start by taking xn to be suppose cos theta n, then we can easily see that xn plus 1 will come out to be root over 1 plus cos theta n by 2. So naturally it is going to be root over 2 cos square theta n by 2 divided by 2. So it will come out to be cos theta n by 2. So on assuming xn by cos theta n, we are getting xn plus 1 to be cos theta n by 2. So we can argue that if we start with assuming x naught to be cos theta, then we can plan that recursively x1 will become cos theta by 2, then x2 will be cos theta by 2 square, and so on and so forth. We can say that this pattern will continue up to xn plus 1, that is coming out to be cos theta by 2 to the power n plus 1. Now for the limiting part, we can analyze that in the denominator we are having continuous product. So first let us see that how this can be obtained. Like we are having x1 into x2 into x3, this way continuous product up to xn plus 1. So this quantity is equivalent to, this is equivalent to cos theta into cos theta by 2, cos theta by 2 to start with, cos theta by 2 into cos theta by 2 square. In this way it will continue up to cos theta by 2 to the power n plus 1. And if you refer to one of my earlier videos on trigonometry, we have simplified this particular trigonometric identity as the result comes out to be sine theta divided by 2 to the power n plus 1 into sine theta by 2 to the power n plus 1. This will be the simplified value of this product of cosine terms with angles are continuously getting halved. So now let us come to the limiting value. The limiting value says limit n tends to infinity root over 1 minus x naught square. Now we have already assumed x naught to be cos theta, so this will come out to be limit n tends to infinity root over 1 minus cos square theta divided by sine theta whole divided by 2 to the power n plus 1 into sine theta by 2 to the power n plus 1. So we can easily see that root over 1 minus cos square theta and sine theta will be cancelled out, so that we are ultimately getting limit n tends to infinity 2 to the power n plus 1 into sine theta by 2 to the power n plus 1 whole divided by theta by 2 to the power n plus 1 multiplied with theta by 2 to the power n plus 1. Now we can see that as n tends to infinity theta by 2 to the power n plus 1, this is definitely going to be a very small quantity tending to 0, because the denominator 2 to the power n plus 1, this particular quantity is becoming very large compared to a finite value of theta. So this whole quantity will tend to 0, so we are getting a format which is equivalent to, our numerator is becoming sine x and the denominator is becoming x, where that x part is going to 0. So this whole limiting part can be taken to be 1. So in the next step we can write this to be limit n tends to infinity 2 to the power n plus 1 into theta by 2 to the power n plus 1, because this whole bracket will be tending to 1. So ultimately 2 to the power n plus 1 cancels to give us a finite limiting answer theta. And according to our assumption, we have taken x0 to be cos theta. So theta can be actually written as cos inverse x0. So this is going to be our answer, cos inverse x0. So we can see option number D is going to be correct one.